We're going to continue with partial fractions today, this time looking at the next section in preparation for 1E, which is section 1.4, I think, which is called repeated factors. Now this is nothing difficult, nothing too tricky, it's just worth pointing out. Let's just do one that we've been used to doing to start with, just to refresh our memory. Now, don't skip past me thinking this is a waste of time. I know what you're like. This is not a waste of time. This is going to prove my point admirably. So, if I gave you that fraction, you would appreciate that on the bottom of that fraction I've got x plus 1, 3x plus 1, 3x plus 1. So it would seem normal and it would seem correct to have x plus 1 b over 3x plus 1 and c over 3x plus 1. That seems logical, doesn't it? That's exactly what we've been doing. In the previous examples, when we had, when we had an x minus 3 and an x plus 1, we put an x minus 3 and an x plus 1. So everything that we've done so far seems to be the logical thing to do. So now we need to put them over a common denominator. So I need to multiply the top and bottom of this one by 2 of these. So I get a 3x plus 1 squared. I multiply the b by one of them and one of them in order to get the bottom to be the same. And I multiply the c by one of them and one of them, like you've been doing in the previous exercise. And that makes the denominator what we want it to be. That would be all three of the bottoms multiplied together, which is exactly what we want. So now we could pick one of our methods. Yeah, we could choose one of our methods in order to do this. So we can now equate the tops, can't we? So I can say that 2x plus 1 equals a 3x plus 1 squared plus, I should have a b there, b x plus 1 3x plus 1 and c x plus 1 3x plus 1. Right, either of the methods now. Let's let x equal minus 1 and we'll see what that gives us. So that on this side we're going to get minus 1, 2 times minus 1 is minus 2, so we're going to get minus 1 equals, well, I'm going to get an a times 3 times minus 1 is minus 3, add 1 is minus 2, and then square it is 4. That's going to be 0, and that's going to be 0. So I get that a is minus a quarter. Right. So, let's see what happens now. So I'm going to swap, and I'm going to start equating coefficients. So let's compare the x squared coefficients. Well, on this side I've got none of them, so 0 equals, now how many x squared have I got on this side? Well, if I expand that, I would have 9x squared times by a, so I've got a 9a. This bracket would give me 3x squared with a b, and this bracket's going to give me 3x squared with a c, and I can divide all of those by 3, so 3a plus b plus c. And let's compare the x coefficient. So I've got a 2 on this side. How many x's? If I expand that carefully, I'd get 6x. So that's 6a. This one gives me x plus 3x. So that's 4x. And this one gives me, it's going to be the same as that, isn't it? X plus 3x, so 4x. And I can divide all of this by 2. Okay. And then I'll compare the numbers. So on this side I've got 1, and on this side I've got an a b, and a c. Right, now we know what a is, don't we? We know what a is, don't we? We know that a is minus a quarter. So let's stick that into here and here. So if I stick it into here, I get 0 equals minus 3 over 4 plus b plus c. So I get 3 over 4 equals b plus c. And if I stick it into here, I get 1 equals minus a quarter plus b plus c. Add the quarter, so I get 5 over 4 equals b plus c. Now, at this point, hopefully, you're saying, well, this can't be right. Here, I'm saying that b plus c equals 3/4. And here, I'm saying that b plus c equals 5/4. So somewhere in this, something has gone wrong. And in fact, it went wrong all the way up here. If you look here, I can, in fact, cancel a 3x plus 1 from all of these from all of those different terms within that fraction. So in fact, the denominator of this side is x plus 1, 3x plus 1, and the denominator of this side is x plus 1, 3x plus 1 squared. So the denominators aren't the same, so there's no wonder that we can't equate them, we can't do this, because our fractions are fundamentally different. We can't set the tops equal to each other, because in fact, these are going to cancel and we end up in a bit of a sticky situation. Okay, so this is a special case. If you've got a repeated factor on the bottom, then we end up in a special case. Okay, and it's easily fixed. The way to fix this is very, very easy. So let's, I'll sort out the camera in 2 seconds. Let me just write this fraction. The way to fix this is very, very straightforward. So, you start with a fraction with an exceptionally cool fraction line. So, we do what we would normally do. So, I'm going to have an a over an x plus 1. And then our gut tells us we want to have a b over a 3x plus 1. And we want something else as well. Now, this something else is going to have a squared. So, you're going to have one of the brackets not squared, and then one of the brackets squared. Okay, so that's how we get around the repeated root problem. What you'll find is that when we put this over a common denominator, one of those brackets cancels like it did before, and we get back to a fraction like this. Let's have a look at what I mean. So, I do a, and then in order to get all of the bottoms multiplied together on the bottom, I need to multiply it by those, which gives me 3x plus 1 cubed. And then I'm going to have a b times an x plus 1 times a 3x plus 1 squared. And I'm going to have a c times x plus 1, 3x plus 1. And then on the bottom of all of this, I'm going to have x plus 1, 3x plus 1 cubed. Okay? And now I can cancel from all of these terms a 3x plus 1. So that becomes a squared. That becomes nothing, and that goes, and that becomes a squared. So let's just write out what I've got. So I've got an a times 3x plus 1 squared. I've got a b, x plus 1, 3x plus 1. And I've got a c, x plus 1, all over x plus 1, 3x plus 1 squared. So now my denominators are the same. I can't do any more cancelling, and now I can do my method. I could set x equal to minus 1 and work out what a is, and I could go through the same process. In fact, let's do just that. And I haven't tested this, so I don't know how nice these numbers are going to be. So wish me luck. So I end up with 2x plus 1 equaling a 3x plus 1 squared, b x plus 1, 3x plus 1, and c x plus 1. Right, I'm going to let x equal minus 1. So this side gives me, so 2 times minus 1 is minus 2, add 1. So I get minus 1 equals, that's going to go and that's going to go. So it's just going to give me this. Stick in minus 1, I get minus 3 plus 1, which is minus 2. Minus 2 squared is 4. So I get 4a. So I get that a is minus a quarter, which is what it was last time. We didn't have a problem with a last time. It was the others that we experienced some difficulty with. Right. Well, let's do what we did last time. Let's equate the x squared coefficient. So I get 0 equals, I'm going to have 9a plus 3b. And then that doesn't have an x squared. And a is minus a quarter. So I get 0 equals minus 9 over 4 plus 3b. So I get 9 over 4 equals 3b. Divide it by 3. So I get 3 over 4 equals b. Let's equate the x coefficients. So I get a 2 on this side, and that's going to equal a 6a, a 4b, and a c. So I get 2 equals 6a, which is minus 6 over 4. Sorry, that's my alarm to remind me that I've got a Zoom lesson in 15 minutes. My apologies. So I've got minus 6 over 4 plus 4b. So 4 lots of that, which is just 3, isn't it? Plus c. So I'm going to take away the 3, I think. So minus 1 equals minus 6 over 4 plus c. Now what is minus 6 over 4? Minus 3 over 2. So minus 1 plus 1.5. So it's just going to be a half. So I get that A is minus a quarter, B is 3/4, and C is a half. So my answer then, looking back at the template that I started with, my answer is going to be, what's A? Minus a quarter. So I'm going to get minus 1 over 4 x plus 1. B is 3/4, so I'm going to get plus 3 over 4, 3x plus 1. And then I'm going to get plus a half, so 1 over 2, 3x plus 1 squared. Now, with any luck, if you expand that, you're going to get back to what you started with. Okay, so the main point of this, this lesson is to tell you that if it's got a repeated factor on the bottom, your brackets have to be whatever the normal one is, whatever the repeated one is, and then the repeated one with a squared. Okay, so that hopefully will allow you to have a look. So I'm in 1.4 at the minute. So there's an example you can look at here. That's example 10. So you can have a look at that. That was really, really similar to the one that I just looked at. They had a repeated x plus 1. So they've got an x plus 1 and then an x plus 1 squared. And again, do the same thing. So they subbed in some values there. And then you can have a look at exercise 1E, which again I'll upload for those people that don't have it. Just have a quick look here. It's wanting you to factorise the bottom of this, isn't it? So you're going to take out an x squared, and then you're going to be left with an x minus 1. Just be really careful with that x squared. You're going to have an a over x and a b over x squared, and then you'll have a c over x minus 1. Okay, so as always, get in touch. There'll be another Zoom help session on Thursday, so shout if you'd like the details for that. I'm also going to upload a polynomial division sheet, which I'd like you to practice next week, because that's going to help you with the next step of partial fractions the following week. So next week, you're going to have a polynomial division sheet, and I'd like you to do, this week, you're going to have a polynomial division sheet, and I'd like you to do exercise 1E. But I'll put it all on Show My Homework. I hope that makes sense, and I look forward to talking to as many of you as possible very soon. Bye.